Okay, let's unpack this. AI feels like magic sometimes, doesn't it?
No.
Recommending your next show, driving your car. It's just everywhere.
It really is.
But pull back the curtain, and where does all that magic really come from?
Data. Vast amounts of it.
Yeah.
And that dependency on data inevitably brings us face to face with a fundamental question.
Privacy.
Exactly. Privacy.
Yeah. And this deep dive, it's really all about that intense relationship,
Yeah.
between AI and data privacy.
Right. We've pulled together quite a bit of material for this one, reports, articles, notes.
A whole stack.
Yeah, trying to trace AI's wild journey, map its incredible reach across industries,
Digging into the data it needs.
and crucially wrestling with those big privacy challenges it throws up and the complex ways we're starting to fight back.
So our mission for you today, what are we aiming for?
Well, we want to cut through the complexity, distill the essential knowledge, give you a crystal clear picture of what's actually happening with your data in this age of AI.
Why it really matters, why it should be on your radar.
Absolutely. And what's being done about it globally, it's about getting informed, fast, and hopefully hitting a few surprising facts along the way.
Okay, let's do it. So maybe rewind a bit first. This AI revolution, it definitely wasn't overnight. Where did the seeds of this begin?
Well, you can trace the core ideas back surprisingly far, really to the mid-20th century.
Mid-century, like
Yeah, Alan Turing's theoretical work proposing the Turing test in 1950 to see if a machine could, exhibit intelligent behavior. That was foundational.
right, and the name itself.
Artificial intelligence. That was formally coined in 1955 by John McCarthy, leading up to that pivotal Dartmouth conference in 56.
Okay, and you saw these early sort of flashes, right?
Yeah.
Like the perceptron in 58.
Yeah, an early neural network concept.
Yeah.
And industrial robots like Unimate in 61. Even those early chatbots like Eliza in 64 trying to mimic conversation.
Interesting steps, yeah. But not quite the AI we think of now.
No, the real pivot came later. We shifted from what's called symbolic AI, very rule-based, logical, basically telling the computer exactly how to think.
Step-by-step instructions.
Exactly. To connectionist AI. And that's where neural networks really came in, fueled by the explosion of data in the 1990s.
Ah, the data. That changed everything.
It really did. And suddenly, AI was doing things that felt almost impossible just years before.
Deep Blue beating Kasparov in chess. 97, yep.
Then AI starts popping up in consumer tech Roomba in 2002.
I remember Roomba.
Ah, yeah. Then Siri in 2011, Alexa in 2014, IBM Watson on Jeopardy,
That was huge.
and AlexNet's image recognition breakthrough in 2012 that really showed the power of deep learning when you have massive data sets.
So now we're deep in the generative AI era, and the pace just feels dizzying.
It is. GPT-2 in 2019, GPT-3 in 2020, and then ChatGPT hitting late 2022 just blew the doors open for public access.
Milestones that used to take decades.
Now they're happening in months. It's incredible acceleration.
And that speed, that's critical, isn't it? Because it means the tech is just racing ahead.
Way ahead of our ability to fully grasp the implications. Ethically, legally, the regulations just can't keep up. Absolutely. And you see the result of that speed and all that data fuel in just how wide AI's reach is today. It's genuinely pervasive.
Think about navigation. Google Maps isn't just finding a route anymore.
No, it's like predicting traffic, optimizing in real time.
Using AI for all that, integrating voice, even augmented reality features.
Or conversational AI. ChatGPT is now multimodal text, audio, images, video.
Yeah.
It understands it all.
And companies are using sophisticated platforms like IBM Watson for really complex tasks, way beyond simple chatbots.
E-commerce is completely powered by it. Amazon recommendations.
The robots in their warehouses, AI for loss prevention in stores like Walmart or Whole Foods.
Even personalized product descriptions, right? Like Lily AI.
Exactly. Automated checkouts, drive-thrus. It's embedded everywhere.
Robotics, too. Manufacturing floors, sorting, recycling.
Navigating your house with Roomba, even social robots popping up in some places.
And healthcare. That feels like a really critical area.
Fundamentally changing. Personalized medicine, AI analyzing medical images, sometimes better than humans accelerating drug discovery, predictive modeling for patient risk.
The stakes there are just incredibly high. These are life-impacting decisions being influenced by AI.
Absolutely. And think automotive. Self-driving cars from Cruise, Waymo, Tesla, using complex computer vision.
Seeing the world, basically.
Yeah.
Detecting objects, tracking lanes.
Sensor fusion, yeah. Making sense of chaos.
Finance uses it heavily. Automated investing, fraud detection,
Insurance risk assessments, simplifying complex market research.
and just general business operations. It's everywhere, helping write code, cybersecurity.
Even fashion design, believe it or not. Defense systems, risk compliance tools. AI is just woven into the fabric now.
So the main takeaway here, for you listening, is that all this power, this incredible reach,
It all comes back to one thing. Data. This widespread collection across every sector is the bedrock.
and that's where the privacy questions really start to stack up. Because when AI gets deeply integrated into critical areas,
The ethical and privacy implications just get amplified significantly.
okay, so let's really dive under the hood then. Let's look at that foundation. The data ecosystem AI needs to actually function.
Right. Data is the fuel, plain and simple. And getting that fuel involves, well, a whole process.
Identifying what data you need first, I guess.
Exactly. Then gathering it, cleaning it up, pre-processing. They call it labeling it, which can be a huge job.
Making sure the AI knows what it's looking at.
Precisely. And then storing and managing it all.
And where does all this data actually come from? It seems like everywhere.
It is incredibly varied. You've got direct methods like surveys or questionnaires.
Okay, asking people directly.
But then you have the massive, often automated methods, web scraping, API integration.
Pulling data from websites.
Yeah, extracting info from public sources like Reddit, YouTube, Instagram. That's crucial for training large language models, computer vision systems.
And there's the first big privacy flag, right? Because this often happens without people, fully understanding or explicitly consenting to their public posts being used like that.
Exactly. That's a huge point. You also have public data sets, free sources from governments, research institutions.
Like Kaggle.
Yeah, places like Kaggle, cost-effective, but sometimes the data is irrelevant, outdated, or carries re-identification risks we'll talk about.
And then all the Internet of Things stuff.
Oh, yeah. IoT data, real-time streams from wearables, smart homes, industrial sensors. It's continuous monitoring, generating vast amounts of data.
So this relentless need for data, it creates a specific dynamic, doesn't it?
It does. We're seeing what you could call digital hoarding. Because the models perform better with more data, there's this aggressive drive to collect everything possible from everywhere possible.
And that hoarding inherently creates, well, ethical problems.
Big ones. Because getting truly informed consent becomes incredibly difficult when data is scraped from countless sources, often for uses that weren't even imagined when the data was created.
Right. And it's not like this data stays separate, does it? It gets combined.
That's the other critical piece. Data from web scraping might be linked with IoT sensor data, maybe with public records. That aggregation massively amplifies the privacy risks.
There was that statistic. Something like 60% of the U.S. population identifiable just from gender, date of birth, and zip code.
When combined with other publicly available info, yeah, it's surprisingly easy to link to data sets.
So the insight here for you is privacy isn't just about locking down one database.
No, it's the risk of linking those seemingly harmless, disparate data points across the whole ecosystem. That's where the real sensitivity can emerge.
Okay, so what kind of data are we talking about? What forms does it take?
Well, you've got structured data. Think spreadsheets, organized names, dates, numbers, easy for databases to handle, good for predictions, CRM systems.
But most data isn't like that, right?
Not at all. The vast majority, maybe 90% or more, is unstructured. Text documents, emails, images, video, audio, sensor readings. No predefined format.
Much harder to process. But that's where the really rich insights are for things like NLP, generative AI, sentiment analysis.
Exactly. Stored often in data lakes. And then there's semi-structured data things like JSON files or XML, email headers, which has some metadata tags to help organize it. Sort of a bridge between the two.
But from a privacy angle, the sensitivity of the data is paramount.
Absolutely key. You have personal information or PI, stuff that links directly or indirectly to your name, address, IP address, maybe location data.
And that's collected constantly, from photos you post, social media, cameras you walk past, fitness trackers.
Often without really explicit, clear consent for that specific use. Then you have sensitive personal information or SPD.
That's the really high-risk stuff.
Yes. Health data, financial details, racial or ethnic origin, political opinions, sexual orientation. Leaking this stuff carries major risks. Legally, it requires much stricter handling, explicit consent, often things like data protection impact assessments.
And then biometric data.
Right. Facial recognition data, fingerprints, voice prints. This is arguably the highest risk category.
Why? Because it's uniquely you.
Exactly. And crucially, you can't change it if it's compromised. If your face scan database leaks, you can't get a new face. It creates a permanent vulnerability.
Wow. There are specific laws for that too, aren't there? Like
Yeah.
BPA in Illinois.
Yes, BPA is a strong example, providing specific protections for biometric data.
So what's really striking here is this trade-off, isn't it?
Mhm.
Between how useful the data is and how risky it is.
That's the fundamental privacy-utility trade-off right there. The more detailed, the more granular, the more sensitive the data.
The more powerful the AI can be, like for personalized medicine or
Yeah.
spotting rare diseases.
Exactly, higher utility. But that also means the potential for harm, if it's misused, breached, or leads to bias, is much, much greater. It's a constant balancing act.
And AI complicates this further because it can infer things.
Yes. AI is getting incredibly good at inferring sensitive attributes, your political views, maybe a health condition from data that seems completely non-sensitive on its own, like, say, your step count patterns or online activity.
So my innocent fitness data could become sensitive.
When processed by a sophisticated AI, yes. And this challenges traditional legal definitions of personal data because the rules weren't really built anticipating this kind of inferential power. It creates a regulatory lag.
Okay, so we have all this data, different types, different sensitivities. How does AI actually use it? What are the mechanisms?
Well, at its core, it's about processing that data using different algorithms and paradigms, from older symbolic rule-based systems to, much more prominently now, machine learning and deep learning.
Machine learning. That's about algorithms learning from data, right?
Essentially, yes.
Wow.
Supervised learning uses labeled examples, like showing an AI thousands of cat pictures labeled cat so it learns to recognize cats, used for classification, regression.
Email spam filters, maybe.
Good example. Unsupervised learning finds patterns in unlabeled data, grouping similar customers together, for instance. And reinforcement learning involves an agent learning through trial and error, getting rewards or penalties, think training AI for games, robotics, self-driving cars.
And deep learning. That's the really complex stuff.
That's a subfield of machine learning using artificial neural networks with multiple layers, deep layers. These handle very complex data like images, video, natural language incredibly effectively.
So that's where you get things like convolutional neural networks, CNNs, for images.
Or recurrent neural networks, RNNs, and more recently, transformers for sequential data like text. Transformers are the architecture behind models like GPT.
And this complexity, this is where the black box problem really bites, isn't it?
It absolutely deepens it. With these complex, deep learning models, it often becomes incredibly difficult, sometimes impossible even for the creators, to pinpoint exactly why the AI made a specific decision or prediction.
It's not just that we humans can't follow the logic.
It's an accountability challenge. How can you trust or audit or fix a model if you don't understand its internal reasoning? How do you ensure it's not harboring hidden biases?
Right. So why is AI so data hungry then? What are the main purposes it's being used for?
Personalization is a massive driver, tailoring experiences directly to you.
Product recommendations on Amazon, the shows Netflix suggests.
Exactly. Customized marketing messages, website content adapting to your profile, it can get hyper-personalized.
Behavioral targeting takes that a step further.
Yeah, predicting your likely actions based on past behavior and context, then delivering tailored experiences or ads in real time. Optimizing ad campaigns on Facebook or Google, mapping complex customer journeys in sales.
Even predicting attacks in cybersecurity.
Yes, predicting adversarial behavior based on patterns. Risk assessment is another huge area.
Predicting things like adverse drug reactions or financial fraud.
Exactly. Predicting patient health events like cardiac issues or mental health crises. Also assessing risks within the AI systems themselves, looking for potential bias or unintended impacts.
And surveillance. That's a big one too.
Increasingly AI-driven. Integrating facial recognition, license plate readers, analyzing data streams from countless devices, sensors, video feeds.
For public safety, retail loss prevention, traffic management.
Healthcare facility monitoring, smart home security, border control, and these new vision language models, VLMs, are making this even more powerful.
How so?
They combine sophisticated image recognition with broad world knowledge. They can interpret visual scenes in incredible detail, not just objects, but events, interactions, even attempting to infer emotions or, controversially, things like social class from images or video. They're like unblinking artificial eyes.
Wow. And finally, optimization. Just making things run better.
Right. Driving efficiency in supply chains, predicting demand, managing inventory, optimizing logistics routes, controlling warehouse robotics, even informing urban planning decisions based on data patterns.
So it's this cycle. AI's utility drives the need for data,
which fuels broader collection and processing.
which enables more powerful AI applications.
But that very dependency is also the source of major friction, major privacy challenges.
Okay, let's get right into that friction, the core conflicts. What are the biggest privacy challenges AI throws at us?
Well, the most direct one is probably data breaches and security vulnerabilities.
Because AI systems are sitting on mountains of valuable data.
Exactly. All that digital hoarding of vast, often sensitive data makes them incredibly attractive targets for attackers. Vulnerabilities can lead to unauthorized access to patient records, financial details, you name it.
And we've seen the devastating scale of past breaches. Yahoo, billions of accounts. Equifax, 147 million social security numbers. Facebook data scraping affecting over 500 million. Marriott.
The list goes on, and often the causes are depressingly common human error, insider threats, weak passwords, unpatched software vulnerabilities.
The consequences are brutal too. Massive fines. Meta got hit with a 1.2 billion GDPR fine. Huge reputational damage. And for individuals.
Identity theft, fraud, serious personal consequences.
But it's not just about stealing the data stores, right? The AI models themselves can be attacked.
That's a critical point. There are AI-specific attacks, data poisoning, for example, deliberately feeding the AI bad or malicious data during training to make it learn the wrong things or create backdoors.
So you could sabotage it from the inside.
Or model inversion attacks, where attackers try to reconstruct the sensitive training data just by probing the model's outputs. Adversarial examples, tiny, almost invisible changes to an input image or sound that completely fool the AI.
Like making a self-driving car misidentify a stop sign.
Potentially, yes.
Yeah.
There's also model stealing, trying to replicate a company's valuable proprietary model. Privacy leakage, where models inadvertently memorize and might reveal parts of their training data. Backdoor attacks, evasion attacks, data inference.
Inferring protected info just from the output.
Yes. And things like prompt injection, manipulating generative AI like ChatGPT to bypass safety controls or reveal unintended information. These attacks show that the AI solutions themselves become vulnerable targets.
Wow. Okay, another big challenge, re-identification of supposedly anonymized data.
Right. This is the persistent risk that data stripped of direct identifiers, names, addresses, can still be linked back to specific individuals.
How? By combining it with other information.
Exactly. Through linkage attacks. Cross-referencing the anonymous data set with publicly available records, social media profiles, other data sources. Sophisticated machine learning makes this easier than ever.
And it doesn't take much, does it? That study suggesting 99.98% of Americans re-identifiable with just 15 attributes.
Or the simpler one. Gender, date of birth, zip code identifying over 60% when linked, and inference attacks, too, using AI to deduce identity or sensitive attributes from the remaining data points and patterns.
This isn't just theoretical, right? There are famous examples.
Absolutely. The AOL search log released back in 2006 is a classic. They replaced user IDs with numbers, thought it was anonymous, but the New York Times was able to re-identify a specific user simply by looking at what she searched for, unique combinations of things like landscapers and Lilburn, Jag, medical conditions, her neighbors' names. Those searches acted as quasi-identifiers. Removing the ID wasn't enough.
Wow. And the Netflix prize.
Similar story, 2007-2008, Netflix released 100 million anonymous movie ratings for a competition. Researchers at UT Austin showed they could link those anonymous ratings to public ratings on IMDb.
How many ratings did it take?
Shockingly few. Sometimes just 2 unique movie ratings shared between the datasets, or maybe 6-8 ratings in total, were enough to identify an individual's entire viewing history in the anonymous dataset. High-dimensional data like ratings is very vulnerable.
And the NYC taxi data leak in 2014.
Yeah, they tried to anonymize taxi medallion numbers by hashing them, but the hashing method was weak and easily reversed. Journalists quickly re-identified drivers and even passengers' trip details, including celebrities visiting specific locations. Poor pseudonymization just doesn't work reliably.
So the takeaway here is re-identification is a systemic risk.
It really is, especially with complex behavioral data. Privacy can't be guaranteed just by anonymizing one data set in isolation. It's the potential for aggregation across the wider data ecosystem that creates the vulnerability. Simple techniques like k-anonymity try to mitigate this, but it's a hard problem.
Okay, shifting gears slightly, but related. Algorithmic bias and discrimination. This feels huge.
It's incredibly important. This is when AI systems produce prejudiced or unfair outcomes, leading to discriminatory treatment in critical areas like healthcare, hiring, lending, even criminal justice.
perpetuating existing societal inequalities.
or even amplifying them. It disproportionately harms marginalized groups, and bias can creep in at multiple stages.
Like the data itself being biased.
Yes, data bias is a major source. If the training data isn't representative of the population, the AI will serve, maybe it underrepresents certain groups, or it contains historical biases. The AI will learn those biases. Selection bias, labeling bias, sampling bias.
How the algorithm is designed can also introduce bias.
Absolutely. Choices made by developers, even unintentionally, can favor certain outcomes or groups, and developers' own unconscious biases can influence the process. Then, during training and deployment, the model might learn from historical inequalities, or overfitting can hard-code biases, or there might just be a lack of rigorous auditing for fairness.
We've seen some pretty high-profile, concerning cases, haven't we?
And unfortunately, yes. Amazon had to scrap an AI hiring tool because it learned to discriminate against female applicants.
Because it was trained on mostly male resumes from the tech industry.
Exactly. It penalized resumes containing words like women's, as in women's chess club captain, and favored graduates from certain all-male colleges.
What about the Compass algorithm in criminal justice?
That's another well-known example. Studies like ProPublica's investigation found it was disproportionately likely to label Black defendants as being at higher risk of reoffending compared to white defendants with similar criminal histories, potentially reinforcing systemic bias in sentencing and parole decisions.
Facial recognition tech has had problems too.
Significant issues. Multiple studies, including ones from MIT and the ACLU, have shown higher error rates, particularly false positives, for individuals with darker skin tones, women, and younger people. This raises serious concerns about misidentification, wrongful arrests, and racial profiling if used by law enforcement.
And in healthcare.
Bias can creep in there too. One study found an algorithm widely used in U.S. hospitals to predict healthcare needs systematically underestimated the needs of Black patients because it used healthcare cost as a proxy for need, and Black patients historically incurred lower costs for the same level of illness due to access issues and systemic inequities. This could lead to delayed or inadequate care.
Even lending. The Apple Card controversy.
Yeah, accusations arose that the algorithm offered lower credit limits to women compared to their husbands, even when they shared assets and had similar credit profiles. It highlighted how bias can manifest in financial systems.
These examples really hammer home the need for what you called explainable AI.
Critically, we need systems that are transparent, understandable, and accountable so we can actually audit them for fairness, identify these biases, and work to mitigate them. Otherwise, we risk automating discrimination at scale.
Okay, another major area. Pervasive surveillance and the erosion of anonymity.
This ties into the AI capabilities we discussed, especially computer vision. AI integrated into surveillance systems, facial recognition cameras, license plate readers enables constant monitoring in public and even private spaces.
Raising fundamental questions about privacy rights, freedom of movement.
Unlawful surveillance concerns, definitely. And those vision language models, VLMs, amplify this dramatically.
Because they don't just see, they understand.
In a way, yes. They combine image recognition with vast world knowledge. They can identify a huge range of objects, actions, events, relationships between people, even attempt to infer things like emotions or social status from photos or video feeds.
And they're becoming cheaper, more accessible.
Exactly. So they're being deployed everywhere. Retail stores, shopping malls, workplaces, public cameras. They can be instructed with simple language commands too, like alert me if someone matching this description enters.
That sounds potentially chilling.
The implications are significant. It's a move toward automated, ubiquitous monitoring these unblinking yet unreliable artificial eyes, as one source put it, scrutinizing every move, noting details about clothing, companions, activities, storing it all in searchable databases.
And the unreliability factor is key too.
Absolutely. Errors can lead to false accusations, misidentifications, grave injustices. It increases information collection, but also adds subjective, potentially flawed AI judgment.
The Orwellian nightmare scenario people worry about.
It touches on those fears, yeah. Tracking individuals via digital IDs, potential for weaponization against activists or marginalized communities. Concerns about circumventing legal protections, like police using real-time facial recognition secretly.
Why should you, listening, care? This isn't sci-fi anymore.
No, it's happening now. It directly impacts your freedom of movement, your freedom of association, your ability to simply exist in public spaces without being constantly monitored and analyzed. That's a fundamental shift.
Then there are deepfakes, the identity manipulation problem.
Right. AI-generated videos, images, audio that are incredibly realistic, so realistic it's becoming extremely difficult to tell truth from fabrication.
How are they made? It sounds complex.
They use advanced machine learning, particularly models like generative adversarial networks, GANs, autoencoders, and diffusion models. With GANs, you basically have two AIs competing. One tries to generate fakes, the other tries to spot them. This adversarial process rapidly improves the quality of the fakes.
And automation makes it easier for anyone to create them.
Increasingly so, yes. The tools are becoming more accessible.
The malicious uses seem terrifying. Financial fraud?
Definitely. We're seeing BEC 2.0 business email compromise scams using deepfake audio or even video to impersonate executives and authorize fraudulent transfers. There was that case of a UK energy company losing around $243,000 to a deepfaked CEO voice.
Identity theft, too. Bypassing security.
Potentially, yes. Using deepfakes to fool facial recognition or voice biometric systems. And disinformation, spreading fake news, propaganda, manipulating public opinion, even disrupting markets with fabricated evidence.
Fake videos of politicians seem common now.
We've seen manipulated videos targeting figures like Kamala Harris, Nancy Pelosi, President Zelensky, often used to incite anger or create false narratives. Blackmail is another risk, creating fake compromising material. And social engineering impersonating trusted individuals in things like deepfake job interviews to infiltrate networks.
Is it possible to detect them reliably?
It's incredibly challenging. The technology advances so rapidly. Modern deepfakes can replicate subtle expressions, voice patterns, even things like heartbeat patterns that older detection methods relied on. It's a constant arms race between creation and detection.
Average people struggle to spot them.
Studies suggest accuracy is often around 50-50. Basically a coin toss. Even experts can be fooled.
The impact on democracy feels particularly critical here.
Absolutely. Deepfakes fundamentally erode public trust in verifiable information and objective truth. It fuels the liar's dividend, the ability to dismiss genuine video or audio evidence as potentially fake, which paralyzes informed debate and decision-making.
Wow. Okay, let's talk about emotional AI. AI that deals with feelings.
Yes, AI systems designed to measure, understand, interpret, and even react to human emotions. It's about turning our intimate emotional states into data points. And it's a fast-growing market, projected to be worth billions.
The privacy concerns seem obvious there. It feels very intimate.
They are significant. Emotional AI infers emotions from a huge range of personal data, text analysis, facial expressions from video, voice tone analysis, even physiological data from wearables or behavioral patterns.
So using AI to analyze someone's emotions during, say, a loan application interview.
That's a potential use case, and it raises serious questions. Depending on the specific data and context, emotion data could be considered personal information, sensitive personal information, or even biometric data under laws like GDPR or BIPA.
There's a tension again with data needs.
Yes. Accurate emotion detection often requires large, diverse data sets, which can conflict with the principle of data minimization collecting only necessary data. And there's always the risk of this highly sensitive data being used for unforeseen purposes later.
And the risk of manipulation.
That's a major concern. If an AI can understand your emotional state and potential weaknesses, it could potentially be used to guide you towards desired actions, maybe unconsciously.
Like the example of social media using it to detect gambling addiction signs and then hitting you with betting ads.
Exactly that kind of scenario. Regulations like the EU AI Act are specifically trying to ban AI systems that use manipulative techniques to cause harm, and they place restrictions on emotional AI in sensitive areas like workplaces and education, though with some exceptions. The US FTC is also targeting manipulative chatbot practices. Transparency is key, knowing when you're interacting with an AI.
And bias is a risk here, too.
Definitely. If the training data lacks diversity across ethnicities, cultures, age groups, the AI might misinterpret facial expressions, gestures, or voice tones.
Leading to misdiagnosis in mental health care, for instance.
That's a potential harm, yes. If the AI misinterprets symptoms or emotional expressions in patients from different backgrounds, regulations are trying to address bias. The EU AI Act, GDPR's fairness principles, U.S. anti-discrimination laws, the Colorado AI Act specifically targets bias.
Circling back to the black box problem, that itself is a privacy issue, right? The lack of transparency.
Fundamentally, yes. The opacity of how complex AI systems, especially deep learning and generative models, arrive at their decisions is a barrier. Not knowing the logic behind automated systems that affect people's lives.
How does that impact trust and accountability?
It significantly reduces trust. How can you trust a decision if you don't know how it was made? It makes it difficult to adjust or fix models if something goes wrong because you can't pinpoint the faulty logic. Security vulnerabilities can be hidden within the opaque layers.
And ethical concerns, like bias.
Exactly. Bias becomes harder to detect, trace, and correct. It makes it harder to ensure accountability for harmful outcomes, like unfair hiring decisions or biased judgments in the justice system. And it complicates regulatory compliance. How do you prove your AI is fair or compliant if you can't explain its decisions?
So the push is for explainable AI, XAI.
Yes. Making the decision-making process transparent, understandable, accountable, trustworthy. Disclosing not just the data used, but the logic applied. It also points to needing more granular consent management, giving users precise control over how their data is used by the AI, and underscores the need for meaningful human oversight, especially in high-stakes situations.
Putting all this together, the intense data demands, the opacity, the pervasive collection, it feels like it fundamentally undermines our individual control, our autonomy.
It absolutely erodes individual data control and, by extension, autonomy. Privacy is widely seen as essential for autonomy, the ability to make choices and live your life without undue coercion or surveillance.
And companies often aren't clear about how our data feeds the AI.
That's a common issue. Vague privacy policies. Is your data just improving the algorithm? Is it being shared with third parties? Will it be used to train completely new models in the future? This ambiguity damages trust and can lead to community backlash, like we saw with Reddit users protesting their data being sold for AI training.
The black box contributes to that feeling of powerlessness.
Definitely. If you can't understand why an AI made a decision about you denied a loan, flag for review, or challenge it effectively, you feel powerless against the system.
And the collection itself often bypasses meaningful consent.
The pervasive scraping of data from public websites, photos, social media, tracking through apps and devices, often the consent is buried deep in lengthy terms and conditions nobody reads, or sometimes there's no real consent mechanism at all. Clearview AI scraping billions of facial images from the public internet without consent is a prime example.
Plus, the inference problem, AI, deriving sensitive insights from non-sensitive data.
Effectively repurposing your data far beyond the original context or your intent. This violates principles like purpose limitation and further erodes your control over how information about you is used.
So how do we counter this erosion? What's needed?
There's a vital need for much clearer, more explicit consent mechanisms, especially detailing how data will be used for AI training. Companies need to update policies, communicate transparently, build robust systems to track consent and usage preferences accurately.
Empowering users with real choices.
Yes, meaningful opt-in and opt-out controls, perhaps with privacy-preserving settings as the default, and strongly upholding user rights defined in regulations like GDPR, the right to access your data, portability, the right to an explanation for automated decisions.
And the right to erasure, though that seems tricky with AI models.
It is challenging, especially for large models already trained on data, but the principle of being able to have your data deleted remains crucial for control.
And this loops us back to that core tension we mentioned earlier.
The privacy-utility trade-off. It's the recurring theme. AI needs lots of data, often granular and sensitive data, to achieve its impressive utility personalization, efficiency, discovery.
But that directly conflicts with protecting privacy.
Exactly. More data, more sensitive data equals higher utility and higher risk. Conversely, strong privacy measures like data minimization or robust anonymization can sometimes reduce the AI's utility or accuracy.
So the challenge is finding that sweet spot, optimizing the trade-off.
That's the central ethical and technical challenge. How do we harness the immense benefits of AI while rigorously safeguarding fundamental rights like privacy and autonomy? It's not simple.
Okay, so given this complex web of challenges, what are we actually doing about it?
Yeah.
What solutions are emerging?
We're seeing action on multiple fronts, broadly falling into legal regulatory responses and technical safeguards.
Right. Governments are stepping in. What does that landscape look like? It feels patchy.
It is dynamic and somewhat fragmented globally. There's no single universal law governing AI and privacy yet.
The EU seems to be leading the way, though, with GDPR.
Yes, the General Data Protection Regulation, GDPR, in effect since 2018, really set a high global standard for data privacy generally. It mandates things like explicit consent, data minimization, purpose limitation, and strong data protection measures.
And gives users significant rights, access, portability.
The right to an explanation for automated decisions and the right to be forgotten or erasure, that's a strong foundation.
And now they have the EU AI Act specifically for AI.
Correct. It's the world's first comprehensive AI-specific law, gradually coming into effect over the next couple of years. It uses a risk-based approach.
So banning the most dangerous stuff.
Yes, unacceptable risk AI like cognitive behavioral manipulation, social scoring by governments, and most real-time public biometric identification are banned. Then there are high-risk AI systems.
Things impacting safety or fundamental rights, like healthcare, employment, law enforcement.
Exactly. Those face stringent requirements. Robust risk management, high-quality data governance, transparency, human oversight, conformity assessments, registration in an EU database, CE certification.
And lower risk, like chatbots.
Limited risk AI like chatbots mainly have transparency obligations. You need to know you're interacting with an AI. Generative AI models also have transparency rules disclosing AI-generated content, preventing illegal content generation, summarizing copyrighted training data. Very high-impact Gen AI models face thorough evaluations.
What about the United States? It's more state by state, right?
Well, primarily, yes. There's no single federal privacy law like GDPR or a federal AI law yet, though there are executive orders and ongoing discussions. But we're seeing a huge amount of activity at the state level. Over 75 new AI-related measures across more than 25 states proposed or passed recently.
What are the common themes in those state laws?
Disclosure and notification are big, requiring companies to tell you when you're interacting with AI, especially in advertising. Utah passed the first state law on Gen AI disclosure, transparency about data sources used for training.
And rules for high-risk applications.
Yes. Similar to the EU, states like Colorado are implementing requirements for AI used in sensitive areas like healthcare, finance, employment requiring disclosures, opt-out rights, appeal processes, and mandatory impact assessments specifically looking for bias.
Bias mitigation is a focus then.
A major focus in several state initiatives. And tackling deepfakes, particularly around elections, with labeling requirements. California has laws on AI transparency and deepfake election content. Tennessee passed the LVI Act protecting voice and likeness from unauthorized AI simulation.
So a real patchwork developing in the U.S. What about other major regions?
The UK is taking a different, more pro-innovation, principles-based approach, relying on existing sectoral regulators rather than a single new AI law. Canada had a comprehensive AI bill proposed, but it effectively died. China has extensive government supervision, with measures requiring generative AI to be lawful, truthful, labeled, and algorithms registered. Brazil's Senate just approved a comprehensive risk-based bill quite similar to the EU AI Act.
Sounds like a real challenge to harmonize all this.
Huge challenges. Regulation consistently lags behind the rapid pace of technological development. We saw this with social media, IoT, and now AI. The black box nature of many AI systems directly conflicts with regulatory demands for transparency and explainability,
And data flows across borders.
making enforcement of purely national laws difficult. Achieving international agreement on standards is hard because different countries and cultures have different priorities. Think Western emphasis on individual rights versus perhaps more collectivist or state-centric priorities elsewhere.
Enforcement capacity varies too.
Widely, and gaps remain. Compliance costs can be high for businesses. Technical safeguards, which we'll get to, can fail, breaches still happen. Implementing AI ethics frameworks in practice is genuinely difficult with opaque algorithms.
That data hunger versus data minimization conflict again.
Always there. Requirements for human intervention can limit the efficiency gains AI promises, and we actually lack good longitudinal data on public opinion about AI governance, which is needed to ensure regulations reflect societal values.
So more international cooperation is needed.
Absolutely. Harmonization of standards, cross-border enforcement cooperation, it's essential for managing a global technology like AI effectively.
Okay, besides laws, what about technical solutions? You mentioned privacy-enhancing technologies, PETs.
Yes, PETs are crucial. They're a set of technologies designed to enable data analysis and machine learning, especially on sensitive data, while protecting privacy. They allow for trustworthy innovation, potentially resolving some of that utility privacy tension.
On federated learning, what's the idea there?
The core idea of federated learning, FL, is train the AI model without bringing all the sensitive data to a central place. Instead, the model travels to the data.
So the training happens locally, on my phone or in a hospital server.
Exactly. The model is trained on the local data, on the client device or local server. Only the resulting model updates summaries of what was learned, not the raw data itself, are sent back to a central server.
And the server just combines these updates.
It aggregates the updates from many users or institutions to improve the central model, which can then be sent back out.
The big privacy win is the raw data never leaves.
Precisely. Your sensitive messages aren't sent to Google to improve Gboard's predictions. The model is updated on your phone. Hospitals can collaborate to train a better cancer detection model without ever sharing confidential patient records. Apple uses FL quite a bit in iOS for things like predictive text and health features.
Are there downsides? Challenges.
Yes. It requires reliable communication between the devices and the central server, which can use bandwidth. The data on different devices might be very different, heterogeneous, which can affect model performance. And it's not completely immune to certain attacks, like model poisoning or inference attacks on the updates themselves, though it's much better than centralizing raw data.
Okay, what about differential privacy? DP.
Differential privacy offers a mathematically rigorous definition and guarantee of privacy. The core idea is to add carefully calibrated statistical noise randomness either to the raw data before analysis or to the result of queries or model updates.
The noise hides individual contributions.
Exactly. It makes it mathematically improbable for anyone looking at the output to determine whether any single individual's data was included in the input data set while still allowing accurate analysis of overall patterns and trends in the aggregate data.
You can quantify the privacy level.
Yes, usually with a parameter called epsilon. Lower epsilon means more noise, more privacy, but potentially less accuracy. Local differential privacy, LDP, is considered even stronger. The noise is added on the device before the data is ever sent anywhere. The central server never sees the true raw data.
Where is this being used?
Apple is a big user of LDP across hundreds of millions of devices for things like learning popular emojis, new words for quick type, health data types, Safari energy usage patterns, without collecting identifiable user data. The U.S. Census Bureau controversially adopted DP for the 2020 census results to protect against sophisticated database reconstruction attacks trying to re-identify individuals.
What's the trade-off here?
It's inherently that privacy-accuracy trade-off again. More privacy, more noise means less precise results, which can be a problem for certain types of research, especially on small populations where the noise might overwhelm the signal. It also requires significant expertise to implement correctly and can be computationally expensive.
And one more, Pete. Homomorphic encryption. HET, that sounds futuristic.
It's pretty amazing stuff, though still largely emerging for widespread use. The core idea is to allow computations like adding numbers or more complex operations to be performed directly on encrypted data.
Without decrypting it first.
Without decrypting it first. You encrypt the data, send it to a server, like a cloud provider. They perform the calculations on the encrypted data, send the encrypted result back, and only then do you decrypt it with your private key.
And the result is the same as if they'd computed on the original data.
Magically, yes. That's the homomorphic property.
The privacy benefit is huge then. Data stays encrypted even during processing.
Massive potential. It protects sensitive information from the cloud provider, from administrators, from anyone who might access the server where the computation happens. It could enable secure collaboration on sensitive data sets like multiple hospitals analyzing encrypted genomic data together without revealing the underlying information. Great for meeting regulatory compliance, too.
What are the catches? Why isn't it everywhere yet?
The main challenge is performance. Performing computations on encrypted data is currently very computationally intensive, much slower, and requires more resources, memory, processing power, than operating on unencrypted data. This makes it impractical for many real-time applications right now.
Different types exist.
Yes, partially homomorphic allows one type of operation, like addition, somewhat homomorphic, limited number of operations, and fully homomorphic, FHE, which allows arbitrary computations but is the most computationally demanding. It also requires specialized cryptographic expertise to implement and manage.
So promising, but needs more development.
Exactly, but it's a very active area of research and development. These PETs, alongside strong legal frameworks, represent our best tools for navigating that tricky path forward.
Wow, okay. We have covered a remarkable amount of ground today. I mean, from the very birth of AI concepts decades ago, its incredible explosion into pretty much every corner of our lives.
To the vast, complex data ecosystems that fuel it.
And then diving deep into the really serious privacy challenges this dependency creates. We talked about data breaches, the surprising ease of re-identifying supposedly anonymous data,
The insidious problem of algorithmic bias and discrimination, the rise of pervasive AI-powered surveillance eroding public anonymity.
the threat of deepfakes undermining truth itself, the risks of manipulation from emotional AI, the accountability black hole of opaque algorithms.
And that overall feeling that we're losing control, losing autonomy over our own information in this data-hungry world.
While we looked at the solutions, the emerging legal guardrails globally, the promising technical safeguards like PETs.
It's clear they're all still evolving, struggling to keep pace, and come with their own significant complexities and trade-offs.
This whole deep dive, it just really highlights that fundamental tension, doesn't it?
It really does. How do we possibly harness the immense potential of AI for good, for efficiency, for solving massive global problems?
While simultaneously safeguarding fundamental human rights. Privacy, autonomy, fairness, trust in information. It's an incredibly complex balancing act.
With no easy answers, playing out right now in real time as the technology continues its relentless march forward.
Indeed. And AI is only accelerating, isn't it? Processing ever more diverse, more intimate forms of data, leveraging powerful new capabilities like multimodal perception, agentic autonomy, where AI can act more independently.
The landscape is constantly shifting under our feet.
So as AI continues to reshape our world, learning from the digital echoes of our lives, maybe here's a final thought for you to consider.
Beyond the laws being hammered out in legislatures and the complex cryptography being developed in labs, what personal responsibility do we have?
As users, as citizens navigating this increasingly AI-driven world, what's our role in being aware of our digital footprint, understanding how these systems work, and actively advocating for privacy-preserving design, for ethical considerations to be baked into the AI we interact with every single day?